Learning goals. Welcome to this learning session on analyzing correlation with scatter diagrams. In this course, we shall address Introduction to Correlation and Variables, Understanding Correlation Types, Constructing Scatter Diagrams, Interpreting Scatter Diagram Results, Practical Applications of Correlation. There will be a quiz at the end to test your knowledge.
Introduction to Correlation and Scatter Diagrams. A scatter diagram is a powerful graphical tool used to visualize the relationship or association between two different variables. Each point on the diagram represents a pair of observations for these variables. This visual representation helps in quickly identifying patterns that might not be obvious from raw data alone. Correlation describes the nature of this association, indicating whether there is an increasing or decreasing trend between the variables. It also reveals the strength of this relationship, showing if the variables move together closely or if their connection is weak. For instance, a strong correlation might suggest a predictable relationship, while a weak one indicates more variability. Scatter diagrams are widely used in various fields, from economics to biology, to explore potential causal links, or simply to understand how different factors interact. For example, a medical researcher might use a scatter diagram to see if there's a correlation between a patient's age and their blood pressure, providing initial insights before more rigorous statistical tests. Types of linear correlation. Correlation can manifest in several ways, each indicating a different type of relationship between variables. Understanding these types is crucial for accurately interpreting scatter diagrams. The primary categories include strong positive, weak positive, no correlation, weak negative, and strong negative. Strong positive correlation occurs when one variable increases, the other variable also increases significantly, and the points on the scatter diagram are tightly clustered along an upward sloping line. An example is the relationship between hours of revision and test results, where more study time generally leads to higher scores. Conversely, strong negative correlation means as one variable increases, the other decreases significantly, with points tightly clustered along a downward sloping line, such as hours of TV watched and test results. Weak positive or negative correlations show a general trend, but the data points are more spread out, indicating less predictability. No correlation implies that there is no discernible linear relationship between the variables, and the points appear randomly scattered. For instance, the number of bracelets worn and test results would likely show no correlation, as these two factors are unrelated. Explanatory and response variables. When analyzing correlation, it is essential to distinguish between explanatory and response variables. The explanatory variable, also known as the independent variable, is the factor that is thought to influence or explain changes in another variable. It is typically plotted on the horizontal x-axis of a scatter diagram. The response variable, or dependent variable, is the outcome that is being measured or observed, and it is expected to change in response to the explanatory variable. This variable is conventionally plotted on the vertical y-axis. For example, in the relationship between a child's age and weight, age would be the explanatory variable, and weight would be the response variable. Identifying these variables correctly is crucial for setting up a scatter diagram and interpreting the results meaningfully. Consider the length of a train journey and the time it takes. The journey length is the explanatory variable, influencing the time taken, which is the response variable. Similarly, average daily temperature would be explanatory for the number of hot teas drunk, which is the response. Nonlinear correlation patterns. While many relationships can be approximated by a straight line, some variables exhibit a nonlinear correlation, meaning their association follows a curved pattern. This type of correlation is equally important to identify, as forcing a linear interpretation on non-linear data can lead to inaccurate conclusions. Recognizing these curved trends allows for more precise modeling and understanding of the data. A classic example of positive nonlinear correlation is the relationship between the radius of a circle and its area. As the radius increases, the area increases at an accelerating rate, forming a curved line on a scatter diagram. This is because the area is proportional to the square of the radius, area equals pi r squared, demonstrating a quadratic relationship rather than a linear one. Other examples of non-linear relationships include population growth over time, which often follows an exponential curve, or the relationship between drug dosage and its effect, which might show a saturation curve. Identifying these patterns is crucial for choosing the correct statistical models to analyze and predict outcomes effectively. Constructing a scatter diagram involves plotting data pairs on a coordinate plane. This visual representation helps analyze the relationship between variables. The first step is to identify the explanatory and response variables and assign them to the x-axis and y-axis, respectively. It is crucial to label both axes clearly with the variable names and their units, ensuring the graph is easy to understand. Next, determine an appropriate scale for each axis that accommodates the full range of your data. This ensures that all data points can be plotted accurately and that the diagram is not overly compressed or stretched. Each pair of data values is then plotted as a single point on the graph. For example, consider the data for average monthly temperature X and money made from coat sales. If the temperature is 4 degrees Celsius and sales are £46,000, you would plot a point at 446. Repeating this for all data pairs, such as 350, 849, and so on, will build the complete scatter diagram. This systematic approach ensures an accurate visual representation of the data. Interpreting scatter diagram results. Once a scatter diagram is constructed, the next critical step is to interpret the type and strength of the correlation it displays. This involves observing the direction of the trend and how closely the points cluster around that trend. A clear upward slope indicates a positive correlation, while a downward slope suggests a negative correlation. The tightness of the cluster of points around the trend line determines the strength of the correlation. If points are very close to forming a straight line, the correlation is strong. If they are widely dispersed, the correlation is weak. For the coat sales example, as temperature increases, the money made from coat sales decreases significantly, indicating a strong negative correlation. This makes logical sense, as people buy fewer coats in warmer weather. It is also important to consider potential outliers, which are data points that fall far from the general trend. Outliers can sometimes indicate errors in data collection or unique circumstances that warrant further investigation. While correlation shows a relationship, it does not necessarily imply causation. Other factors might be at play, and further analysis is often needed to establish cause and effect. Practical applications of correlation. Understanding correlation extends beyond academic exercises. It has significant practical applications in various real-world scenarios. Businesses use correlation to identify relationships between marketing spend and sales revenue, helping them optimize advertising strategies. For instance, a strong positive correlation might suggest that increased investment in a particular campaign leads to higher profits. In healthcare, researchers might correlate lifestyle factors like diet and exercise with health outcomes to identify risk factors for diseases. A study might find a negative correlation between regular physical activity and the incidence of heart disease, providing evidence for public health recommendations. This helps in developing preventative measures and improving overall public health. Economists frequently use correlation to analyze market trends, such as the relationship between interest rates and consumer spending. A negative correlation might indicate that as interest rates rise, consumers tend to spend less. This information is vital for policymakers to make informed decisions about monetary policy and economic stability, impacting millions of lives.
Summary. Well done. You have completed the course Analyzing Correlation with Scatter Diagrams. You should now be familiar with Introduction to Correlation and Variables, Understanding Correlation Types, Constructing Scatter Diagrams, Interpreting Scatter Diagram Results, Practical Applications of Correlation. Should you need to revisit any of the topics in this course, please use the menu at the bottom of the screen.